All right, students, this is page 2 of the review. So we start off with our properties of logs. Okay, so here we have at number 7, we have a bunch of multiplication. If we have multiplication, that becomes addition of the logs. Right, so we have 3 things that are being multiplied together. Okay, so that means we're going to have 3 logs being added together. And now we're going to apply the property where your power becomes a product. So the 2 is going to go in front of that log to get this answer. Just like that. Okay, so now let's look at number 8. So this one's all similar, right? We have 3 things that are being added together, and there's an x squared. So we're going to have 3 logs that are going to be added together. Sorry, those are being multiplied. So we're going to end up with 3 logs being added, and your 2 is going to come to the front of the log that's going to have x with it. So your final answer, all in one swoop, is going to look like this. Something like that. So let's look at our third example of this style. Oh, here's a whole bunch of stuff. So the first thing we have to do is change our division. Division of our fraction changes into subtraction of the logs. It's subtraction of the stuff on top, or it's the natural log of the stuff on top minus the natural log of the stuff on bottom. Okay, so to start, we split it up like this. Now we're going to deal with this product here, and we're going to deal with this product there. Okay, now it's going to come after a minus sign, so if we want to, we can put all of this stuff in parentheses to let us know that all of this was together in a numerator. So parentheses ln 5 plus ln z cubed. Okay, because multiplication turns into addition. And then the last thing we are going to do is take your powers and move them to the front of just the thing that they belong to. So 2 natural log x plus natural log y. And then minus, I'm going to take the parentheses away, so distribute the minus. ln 5 minus 3 ln z. So those are the expanding, right? When we're asked to expand, we want to have a lot of logs, a log for every single term that we have where you start. Okay, so we had 4 terms to start, so we have 4 logs added and subtracted together. Okay, so the next group is about condensing, right? We're going to condense or compress. I think condense is a better word. So we're going to do the opposite. First, we're going to bring this to the power, right? So that's going to be n squared. And now subtraction becomes division. Okay, so it's always 1 log. So log base b is only one thing, and then we have our fraction. We don't have logs in the numerator and in the denominator. We only have the log of the fraction. So you could put this in parentheses if you wanted to remind yourself that the log does not belong to the top or the bottom. It belongs to the whole entire fraction altogether. Okay, so similarly over here for number 12, first we make these into powers. So v cubed and u to the 4th. And now plus becomes multiplication. So it's log base 5 of one product. That would be u4 v3. Okay, so this does not need parentheses, but if you need them there to remind yourself not to log every single term, then you can do that. Okay, so condensing is usually easier than expanding. So 3 comes to the here, right, is a 3x to the 3rd power, z to the 1/2 power, right? Anytime we have a multiplier in front, it becomes a power. Subtraction becomes division. So x cubed on top and z to the 1/2 on the bottom. Now our last thing we're going to do is take our 1/2 of z and write it as the square root. Okay, so don't leave a fractional power. That's not an x in there, that should be a z. Come here, little letter, you need to be a z. And the natural log of the fraction, right? It's one natural log out front, not a natural log on top and on bottom individually, but the natural log of this fraction. And our last one, this one's pretty cute, right? This becomes the 1/3 power for 8. This becomes the 1/2 power for 9, and that's just ln of 6. So first we do the addition. Addition becomes multiplication. So natural log of 8 to the 1/3 times 9 to the 1/2 minus ln 6. And then subtraction becomes division. So natural log of 8 to the 1/3 times 9 to the 1/2 over 6. Okay, so now let's trade. The 1/3 power is the third root. The 1/2 power is the square root. The third root of 8, that's a real number. The third root of 8 is the actual number 2. The square root of 9, that's a real number. That's 3. 2 times 3 is 6. 6 divided by 6 is 1. The natural log of 1 is what? 0. The natural log of 1 is 0 because e to the 0 equals 1, right? The answer to a log is an exponent, so this answer is 0. Okay, that's why this one's kind of cute, because you can actually evaluate these numbers, right? We're taking the cube root of a number rather than an x or a y or a z. Okay, so expanding and condensing, right? We're using properties of logs to do that, to write it as one log or to write it as a bunch of logs. All right, now let's turn our brains on, because all of these ones are thinking problems. So I think I'm just going to go with these 6, and then we'll move over to do some more. So each of these are thought processes, right? We want to look at the base. We'll make this equal x. We'll make this equal something. Question mark sounds good. Okay, what is the base for natural log? Base e. So e to the what power equals e to the minus 14. Okay, and of course, if your bases are the same, then your exponents have to be equal, so the answer is negative 14. Okay, it also uses a property that says if your bases are the same, all that junk cancels out. Okay, that's the inverse properties of exponentials and logs. So looking at 16, the base of my exponential is 5, and the base of my log is also 5. Right? This is one of those inverse properties. If the bases are the same, the answer is your exponent. So 3t is the answer for 16. If the bases are the same, the answer is your exponent. Okay, number 20. Log without a base is assumed to be log base 10. So we can rewrite this as 10 to the what power equals 0.1. Well, 0.1 is also known as 1/10. 0.1 is 1/10. So can I bring my fraction into the numerator? That's the question. And I can if I make the exponent negative. Okay, this is something you need to know how to do. To take a fraction and to change it into a non-fraction, you raise it to a negative power. So the answer is negative 1, because the answer to a log is the exponent. Okay, looking at number 21, that says 4 raised to the what power equals 16. Okay, and of course, hopefully you know that 16 is 4 squared, so the answer is 2, because 2 is the exponent. The answer to a log question is an exponent. Okay, back to 25. Remember, natural log is log base e. So this one says e to the what power equals 1. And like we just found a minute ago, anything to the 0 power equals 1, so the answer is 0. Okay, 26, remember this is log base e, so our bases are the same, right? E and e are the same, and the answer is your exponent. So all of these are thinking problems. You have to think about what is the exponent going to be in order to make this true. Okay, 17 uses that same property, or that same principle. The base is 7, the base is 7, so the answer is 4, the exponent. Okay, 18, the base is e, our base is e for natural log, so the answer is 2x. Okay, when you recognize this property that when the bases are the same, the answer is your exponent, makes some of these problems pretty stinking easy. Okay, how can we rewrite the square roots? That's x to the 1/2 power, or rather in this case, 7 to the 1/2 power. So if I have a base of 7 for my log and a base of 7 for my exponent, then my answer is 1/2, the exponent, right? Down below, 27. How can I rewrite the 1/3 root? We can rewrite this as 5 to the 1/3 power. So I have a base of 5 and a base of 5, so my answer is 1/3. Okay, number 23. 16 to what power equals 2? Okay, so we're going to do some sideways thinking or some backwards thinking and go this direction. 2 raised to the what power equals 16? Okay, how many 2's do I have to multiply together in order to get to 16? And the answer is 4. So if 2 to the 4th equals 16, what root do I have to take in order to go from 16 to 2? I have to take the 4th root. If 2 to the 4th equals 16, that means the 4th root of 16 equals 2. And how can I express the 4th root as a power? To the 1/4 power. Anytime we're taking a root, you're going to get a fractional power. Okay, 28. Remember, this is base 10. 10 to the what power equals 10? The answer is 1. So whenever the base and the argument are the same, the answer is 1. Right? And anytime we're taking the log of 1, the answer is 0. Okay, so if it's the log of 1, the answer is 0. But if the bases are the same, the answer is 1. Okay, these cancel out. The base of 3 and the base of 3, the answer is 25. Okay, 24 says 4 to the what power equals 1/16. And this one was just like number 20 on the other side. I'm going to write 16 as 4 squared, right? 16 is a base 4. I'm looking for something with a base of 4. And how do I take my exponent out of my denominator? By making it negative. By making it negative. So anytime you want a number to turn into a fraction, you raise it to a negative power. Okay, a negative power. And then 29, 32 to what power equals 16? Well, probably nothing, but we're going to rewrite 32 and 16 as a common base. So 16 is 4 squared, but not 32. So we have to go all the way down to a base of 2. How many 2's multiply by each other to get to 32? 5 of them. So 2 raised to the 5 question mark equals 2 to the 4th, because 16 is 2 to the 4th. So when your bases are the same, that means your answer comes from your exponents. So we're going to make a little equation involving 5, question mark, and 4. 5 times what equals 4? We'll divide both sides by 5 and you get your answer. So this answer is 4 over 5. 32 raised to the 4/5 power gives you 16. Okay, so that's all thinking we want to think about, and the answer is your exponent. The base raised to what power equals that number? Now these last sets here, 30 to 35, are using our rearranging of the furniture algorithm that looks like this. This right here is your rearranging of the furniture algorithm to take an exponential into a logarithm. So the base of your exponent becomes the base of your log. So let's look at number 30. The base of our exponent is 3. So we write log base 3. Okay, this is your, this is your triangle. This is your blob, right? The exponent is your triangle. So then y goes next equals x, the exponent. Because the answer to a log is an exponent. So x was your exponent. That's what's by itself on the other side of the equal sign. Okay, so with number 32, log. This exponential has a base of p, right? And then we have your blob, which is over there. W equals k, which was your exponent. Okay, again, log. The base of our exponent is 3 of 81 equals 4. Okay, so we're just rewriting. We're not asked to solve. We're not asked to simplify. You just want to rewrite the exponential as a log, right? You're just rearranging your furniture, moving your bases and your blobs and your powers. So this is going the opposite direction. Okay, your base of your log becomes the base of your exponent. That should be a 4. So 4 raised to the 2nd power equals 16. Natural log is log base e. So e to the 2.794 equals 8. And then our last one, 100 to the 1/2 power equals 10. Okay, so there's the majority of the second page. I'll make another one for the bottom.